infrastructure, we spoke about this. It's build, maintain, protect. So building, sometimes you derive some architecture that is like, I don't know, someone did it and you have to deal with that. So you have to be careful and decide what to change, what not to change, and you have to come up with the infrastructure that can scale. So it can be solid, but if it doesn't serve business needs, it doesn't scale, it doesn't let you experiment, then you're creating a problem. And again, because of development operations conflict, and you should understand they have two different goals. Like development wants to change stuff, they want to experiment, and operations want to keep it stable. So, and they fight. Pretty much every single organization you take, I can tell like 4 different parties that constantly fighting: product, QA, operations, and development. So product is kind of aligned with development, but QA and operations, they are on opposite sides. So QA doesn't want anything to change because every single change would mean it's going to break. Same with operations. So, but there is a solution. So if you have a good infrastructure, good tooling, like observability, whatsoever, then you can help them actually to change stuff, but then quickly identify and quickly fix this. So the maintenance part. So monitoring is kind of part of building a good foundation. So you have to be able, if organization is like structured that way that operations is in charge but not developers, then someone has to basically monitor. And patch systems, which is, I think, with current stuff, it's not much happening. Before it used to be just going into servers, fixing things, but now you can just ship IAMs or Docker or whatever, like containers, or with serverless, you don't even deal with those kinds of things, like somewhat. So basically, patching and improving, that's something we should do. And protecting is security, disaster recovery, compliance built in, and here important topic, security. We had cases. I don't know if you guys had, but sometimes we have left with a message in MongoDB. It's like, pay me crypto and I'll return your data, because I don't know, someone failed to put the right password. So this is happening to all of us. Hopefully early stage that you don't lose much of developer user data, or you have a backups you can restore, which is a second point. So disaster recovery, I don't know how much you guys realize that, how critical is that? Like imagine CEO getting a message that data is gone. So it's like entire user database is gone. So it's like, it's nothing, basically it's end. You can close the door and run because business is gone. So how critical is that? What are the measures you can take? So what I'm trying here to say, I'm not going to talk about disaster recovery specifically, but that's something we should take care, and we shouldn't forget that part. And also, sometimes you have to tell business what to do. Like you have to just remind them about all those like business critical infrastructure things you have to take care, because business also is thinking about growing, increasing the market. So they fail to realize, but it's not on them. It's also on us, because we are protecting this part. Those are the responsibilities I'm trying to everyone be aware of. So you guys have to tell business that this is a big risk. So anyway, so we'll cover that. Why I'm talking about those points, because before getting there, so again, mentioning infrastructure is not a project. It's like something that is going to constantly change, and you have to chase, trying to fix it, trying to make it stable. So go read a SRE book from Google. It's going to help you to negotiate or find a framework to deal with the business. So basically it's continuous process. Just be aware of that. So the challenges I briefly touched already. Performance. So I think you can sequence this problem. So if you don't have a product that is running, it's stable and performant enough, and enough is again something you should negotiate with the business. It doesn't make sense to think about the other stuff, like it shouldn't be evolving fast, it shouldn't be secure, disaster recoverable, because it has to first serve users, and then you worry about saving users' data. So that's why it's here first. It should be stable. Like standard problems is like it's failing once in a while, customers are not happy, they're gone. There's latency issues, there's spikes and whatsoever, people are frustrated and you don't have much control, and eventually your competitor can just take them away. So those are again things you have to monitor and remind business. So spike protection, this is also common stuff we get. Usually You can put it under loads, and in your lab, it's fine to see some things, but you have to understand user activities, what can happen, and basically test against that. So that's also a common problem we're experiencing. So recently, as a context, we received a couple of interesting projects at DasMeta that are like on thousands requests a second, which is a lot for us. We're a rather small company, and it was challenging basically to be able to tune default AKS from AWS, because it comes like a default setting, so we had to chase and understand behavior and tune it. So that was first time for us to deal with this kinds of problems that do basically expect something from the vendor work out of the box, but it doesn't. So because your use case is above average sort of line. So yeah, then architecture, I also touched this. So you want your architecture to be robust, it can scale, it can serve developer needs, different use cases, and here it's important to understand like how much do you spend on actually maintaining this infrastructure, because if you do create snowflakes, customize stuff to serve this or that need, then you will not be able to maintain this. You'll need like, I don't know, I've seen 50 developers, 30 DevOps trying to follow, because they failed to standardize. They were using like 3 different clouds, and they really couldn't, with 30 DevOps, couldn't really keep up with whatever mess and snowflakes they've created. Eventually, we helped them to shrink it to just the one cloud and standardize and layer whatsoever so that they can handle it. But basically, that was a bad architecture and the design problem. So second point is that, so over-engineering. We're nerds. We enjoy building stuff, and we can sell this kind of stuff sometimes, which is unfortunate because we just create some things that no one needs. Actually, we should rather trying to solve a problem we should rather choose to just remove that problem. Maybe that's like that problem shouldn't exist. So we need to seek to simplify. It's nice to live in your own game world where you come up with some fancy things, justify, and even your coworkers, they got the buy-in, but we're creating just a lot of sort of cost for business. And it's not just the money that they're paying our sellers. It's also opportunity lost because instead of trying to maintain some infra, they could just build a feature or something. So be very careful with that. And stick to whatever industry is like choosing. So forget about this weird shell crap you've created. Just throw it away. So disaster recovery is like also mentioned. So we fail to pay enough attention. There is a book, something about DevOps. I forgot to recall, but basically what is happening in this book is like there's a guy who tries to constantly warn the management that there is compliance problem, disaster recovery problem, and he fails communicating that. As a result, they just lose a very important part of their business. So again, same story. Be careful there. So second part is security compliance. Again, make it secure, make it enough secure. Just understand what is the enough. So enough is, again, business terms. If you talk SRE, for example, availability should be in this level, latency, security. So come up with this whatever currency that you can negotiate with your business and justify. So it's, again, infra and dev also. It's not about tech. There is a lot about, like you remember, Jeff was talking about getting more social skills, like communication skills, because AI is taking over technical parts, so we cannot be nerds anymore. We should be a bit more people. So the people part. So the other common problem is that the costs are high, which I already mentioned, because of people. Like we over-engineer, we justify our existence, and then at the end, company is going almost bankrupt, so they have to lay off a lot of people, and then we cannot understand why this happened. And we constantly always pretty much blame, okay, management did a bad job, they couldn't sell the product, but you don't see that competitor with smaller team with less costs is basically created better product, and that's why you lost the market as a business as a whole. And then they had to cut off, they have to do something, so they lay off, or the entire company is gone. So that's we should always be careful about those things. So Snowflake, I mentioned that. So and buzz factor. So snowflakes are basically it's a knowledge that is somewhere that is not shared, or if one person is gone, then the bust factor. If a person hit by bust, then how much of the business or money is lost basically. So, and the last one, delivery process is messy. So there's no streamlining, I don't know, no pipelines, stuff is done, I don't know how. Again, as a result, high costs and basically problems. So high availability. Why is this? What are we talking about? How is it connected with the previous points? So as a result, since we have to make system scale, we have to explain the system how to scale, and that would mean code. So we are basically translating our knowledge of how system works into some structure that can make things scale and make multiply. And as a result, we're basically, I've told it again, so knowledge is put somewhere. So this is solving many problems. It's load balancing. So you can scale, serve many customers. You can handle spikes if you tune good enough. You can do maintenance with zero downtime. So a bunch of things come with this. And then elasticity, it brings you have to be careful with elasticity in all levels. And we're in AWS context, so AWS has all those tools to be able to achieve this high availability. And redundancy, so if something fails, then you have another thing that is taking care. And it's cost effective, so it can shrink down when there are no users if you tuned it good enough. And basically there is there's this debate that on-premise stuff is cheaper, AWS is more expensive. But if you compare basically this flexibility, which is lost opportunity, and then also human cost, which I think we are getting this money because we're infra guys. But again, if we take the risk that we're creating for a business, I think it's not good to stay somewhere which can sink sometime soon. It's rather be somewhere that is really performant and can gain markets, and then we receive bonuses and we're stable. So we know we're going to get more money, I don't know, longer. So, okay, to achieve high availability. So, given you convinced that that's a solution to the problems I was describing, which I don't know might not necessarily be the case, but so we have a couple of options to achieve this high availability. And no cloud is bare metal or Hetzner. You might be familiar with the Hetzner or whatever, conventional. Sorry. Yeah. So basically, you can use that. You have a semi-cloud option, which is DigitalOcean. We have Heroku, a bunch of things that give some sort of flexibility, but it's not fully auto-scaling or capable of doing stuff. And then we have full hyperscalers. Actually, there are, I think, 3 proper ones. And I recently learned about Oracle, that they are decent enough and cheap. But I'm not convinced on that. One colleague from Munich was trying to convince me. So basically, you know your options. So you have those 3. I could say also you can put the server in your own closet, but let's be serious here. So evolution, old cloud. It's high capital cost. You have to buy servers. It's not easy to scale. You have to buy more machines. So maybe we can skip this slide completely. It's rather manual, so a lot of human cost, and you have to over-provision, otherwise during peak times you're gone. So second option is semi-clouds. It's they are scalable, but not in all layers, plus they are not providing good enough options to, so it's not just about scaling, it's also about securing and other stuff. So basically you need to be flexible enough to serve different business needs. It depends on pretty much what is your customer base. Are you B2B? You have to be compliant, and a bunch of things you have to base your decisions on. But basically, we know that semi-clouds are kind of limited on that. So the question is, what do you want to train yourself on? Do you want to go full-blown all the flexibility that you can serve basically many customers, which we have chosen actually to be with AWS because of this. So we can provide same service to all customers. And also the semi-clouds aren't good global enough. You can combine Cloudflare, some other services, but it's questionable. So, and then we go hyperscalers, global reach, a lot of services that pretty much everything scales. of course with limits, but it's good enough to actually serve 90% of the cases with just 10% effort. And it's easy to also be certified. So I don't know, you have to be also mindful, are you dealing with this SOC2, ISO, blah, but since you have to take care of this whole reliability, security, blah thing, it's always to go with something that you don't have to be certified, but it's better in your mind and with your code base and your skills be certified, because